Okay, so let's move on to the study of measuring the relationship between different variables. We have seen the dispersion of data, the techniques we use, covariance, standard deviation, and the coefficient of variation, and also mean, median, mode, central tendency, and these techniques tell us the dispersion of our data. So now we're going to study the relationship between different variables. For that fact, first we're going to study about covariance. So covariance is a measure that tells us the relationship between two variables, and it tells us by positive, negative, and zero values. So if the covariance value is positive, we say that the two variables have a direct relationship with one another, which means that if one variable increases, the other variable also increases. And a negative covariance value would indicate that if one variable is increasing and then thus the second variable would be decreasing. This exhibits the inverse relationship between the two variables, and the zero covariance tells us that there is no relationship between the two variables. I want you to relate the mathematical understanding to the correlation matrix we saw in the visualization techniques. The correlation matrix actually shows us the values, and the values which we saw are basically derived from the covariance and another concept which we will see shortly. And these two concepts ultimately make the correlation matrix. So after this lecture, you will be able to understand the correlation matrix in a much better way, to have a mathematical understanding and an intuitive understanding, which will help you interpret the correlation matrix in a much better way. So if you want to visualize the covariance, we can say that if we plot the values of two variables on x and y axis, if you see a downward diagonal progression in which if we increase the values of x, the values of y would decrease, which we would say that there is a large negative covariance. If you have, after plotting the data, you see that there is no progression in the data, neither towards upwards, downwards, and the data is just spread out haphazardly and clustered, and there is no progression. After visualizing it, you would say that there is zero covariance. And the last one would be the large positive covariance, in which you can say both the variable values are increasing. If either one of them increases, the other one will also increase. So the progression is towards the top, and we would say that it is a large positive covariance. Let's look at the formula for calculating the covariance. It's important to understand the formula, although the fact that we have a lot of Python packages and you might never be able to write the Python program or maybe any sort of programming to code or to even use the covariance formula, because there are packages and tools for that. But it's always better to have a better understanding, a mathematical understanding, so that you're in a better position to relate these concepts with whenever you are applying it to. So the formula itself, you do not have to, I do not recommend you to memorize it, but at least study it so that you can have a better understanding of it. So over here, what we're doing is that we're taking two variables, x and y, and if you can remember, we're doing something similar to the variance. You remember that, right? So we're taking the x value and we're subtracting it with its mean, and we're doing it the same for y value, and we're multiplying the result, and then we're going to repeat it with all the x and y values and multiply them, and then do a summation of them. So you can say that this is quite similar to the variance formula. The only difference is that instead of one variable, we're taking two variables and we're multiplying them after performing the subtraction with their means. And we're dividing them with n-1 like we saw it before. The concept over here about n-1 is the same as of variance, in which we want to compensate the lack of information of our sample dataset to approximate to the population dataset. So the next concept is correlation. So the covariance actually tells us the relationship, the directional relationship. I'm emphasizing on the word directional because the positive and negative sign tells us the direction in which the data is progressing. So the correlation it tells us the strength of a relationship. So after covariance, you actually know that the direction of our data, but you do not know what is the quantifiable value, about how strong is the relationship. you know the direction, right? It is positive, but how much positive? Like, what is the one value that you can use to compare it with another set of variables? And that value which we would refer is the correlation. So the formula for correlation is pretty simple. We take the covariance, we've calculated the covariance before of x and y, and we divide it by the product of standard deviation of x and the standard deviation of y. So this is an example in which we are considering two variables, temperature and the number of customers. So as you can see, the first step is to calculate the mean of x and y, which we will be using in the formula of covariance. So the first step is to calculate the mean of x and y. The second step is to, after you calculated the mean, you're going to subtract the x and the y with its mean, and we have a couple of rows in which we just repeat the process, and then we're going to calculate the product, right? So we're going to divide the whole formula into small steps. So it is easy for us to keep track of our work and helps us to keep well documented calculations. It's very impractical to do it nowadays, but it's still very helpful to understand it. So the first step is subtraction with its mean. Then the next step is the product of the two values. We're going to sum the column product. We're going to sum all these values. And then we're going to divide it by the total number of the data set minus 1. So the important fact is over here is to consider that the number of values of x should be equal to the number of values of y. Otherwise, there would be a problem because we have two different variables that have different number of values, which is highly unlikely whenever we are dealing with data sets and numbers. In machine learning or in any other statistical analysis, it is usually that we take the same number of values for the both variables. So after calculating the covariance, we're going to calculate the correlation. And the first step is to calculate the standard deviation, because we're going to use the standard deviation, the product of standard deviation of x and y, and divided by the covariance. So first step, we're going to calculate the standard deviation by subtracting it with its mean and squaring it like we saw earlier. And then we're going to divide it by the covariance, and it gives us a value in points, 0.8. So it's important to note that the correlation is always between the values of 0 and 1. So 0.8 would indicate that there is an 80% strong relationship between the two values, which means that there is a high correlation. These two variables are highly correlated, which would mean that if I increase x, there is an 80% chance that y also increases.